Before we begin section 1.4 on quadratic equations, note that there is a prerequisite on factoring polynomials before section 1.4 in MyLabs Plus. For examples and review, you can reference your section R4 in your ebook. Section 1.4 again is on quadratic equations, and we're going to start out by talking about quadratic equation in one variable. In your gray box, your definition for that, and it says an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, with a not equal to 0 is a quadratic equation. The given form is called standard form. So as we move forward to solving these equations, it is important that you know that your standard form is ax squared plus bx plus c equals 0, with all of that being on one side of the equation and your 0 being on the other side. The next thing that we're going to talk about is your zero factor property. And it says if a and b are complex numbers with a, b equal to 0, then a equals 0, or b equals 0, or both equal 0. So as we move into example 1, we're going to solve this quadratic equation using the zero factor property. And so it is important that you note that either a equals 0 or b equals 0 or both. So as we look at example 1, solve 6x squared plus 7x equals 3. Then again, it is important that you note back on the original standard form that we talked about, and that is ax squared plus bx plus c all needs to be on the same side of the equal sign. So that's the first thing that we want to do. We want to write this as 6x squared plus 7x minus 3 equals 0. And once you have written that in standard form, then you want to factor your equation. And when we factor this equation, we get 3x minus 1 times 2x plus 3. And again, this is where your zero factor property comes in, because we know that 3x minus 1 equals 0, or 2x plus 3 equals 0, or both. So we want to rewrite these, setting them equal to 0. So we have 3x minus 1 equals 0, and we have 2x plus 3 equals 0. And when we solve 3x minus 1 equals 0, we move that 1 to the other side, making it positive. Divide both sides by 3, and we get x equals 1/3. Or when we solve 2x plus 3, we move that 3 to the other side, we get 2x equals negative 3. Divide both sides by 2, and we get x equals negative 3 over 2. So again, using the zero factor property, then you want to first make sure that it is written in standard form. And once you factor that, then you want to set each factor equal to 0 and solve for x. Before we move into example 2, then we're going to talk about the square root property. I'm going to move this page out of the way. So in your gray box on the top of the next page, you see your square root property, and it says if x squared equals k, then x equals the square root of k, or x equals negative square root of k. That is, the solution set of x squared equals k is the square root of k and negative square root of k. Now this can be abbreviated as plus or minus the square root of k, but please note, as you'll see here, that when you're entering your answers in MyLabs Plus, they require these answers to be separated like we have written it here. So instead of writing plus or minus, you will want to separate that and write positive square root of k, comma, then your negative square root of k. So be mindful of that as you enter your answers in MyLabs Plus. Now, in example 2, we are going to be using the square root property to solve these quadratic equations. So if you look at example 2, part A, we have x squared equals 17. So according to your square root property, we can take the square root of both sides of the equation. So that gives me the square root of x squared equals the square root of 17. Now the square root of x squared is x, and the square root of 17 is plus or minus the square root of 17. Now just like when we were reducing our radicals earlier, you want to see if your square root is your radicand is a perfect square, and if it is not, you want to see if it can be broken down. Since 17 is not a perfect square and 17 cannot be broken down into a perfect square and a non-perfect square, then we are finished and your final answer is plus or minus the square root of 17. However, keep in mind that when you enter this answer in MyLabs Plus, they will want this written as positive square root of 17, comma, negative square root of 17. For part B of example 2, we have x squared equals negative 25. X squared equals negative 25, and you will start this the same way by taking the square root of both sides. So we have the square root of x squared equals the square root of negative 25. And the square root of x squared is x. When we take the square root of negative 25, keep in mind what we learned about complex numbers last section. So this will be the same as plus or minus I square root of 25. And when you look at that square root of 25, 25 is a perfect square, and the square root of 25 is 5. So this is x equals plus or minus 5I. But again, keep in mind, when you write this answer in MyLabs Plus, it will be positive 5I, comma, negative 5I. You will want to separate those in MyLabs Plus. As we move forward and we look at part C, then you will see that we have x minus 4 squared equals 12. And you will work this the same way. So don't let that confuse you that you have x minus 4 quantity squared equals 12. You will still start this equation by taking the square root of x minus 4 squared on the left and the square root of 12 on the right. Now, if we have x minus 4 squared, that's the same as saying x minus 4 times x minus 4. So the square root of x minus 4 squared will simply be x minus 4. And the square root of 12, 12 is not a perfect square, but it can be broken down into plus or minus square root of 4 times the square root of 3. Now, your perfect square is 4. So the square root of 4 is 2. 3 is not a perfect square, so it will stay square root of 3. Now remember, we still want to solve for x. We want x on one side and everything else on the right. So we're going to leave this x where it is, but we're going to move this negative 4 to the other side, making it positive. So we get 4 plus or minus 2 square root of 3. And again, in MyLabs Plus, we will write this as 4 plus 2 square root of 3, comma, 4 minus 2 square root of 3. So again, I know that I've reminded you on all three parts, but do not forget that MyLabs Plus will want those answers written separately. So that is example 2 using the square root property. Now, we are going to skip over to example 5. If you're following along in your ebook or along with your notes, And when we start with example 5 and 6, then we move into using the quadratic formula. So again, I'm going to switch pages. Alright, so the quadratic formula says the solutions of the quadratic equation ax squared plus bx plus c equals 0, where a is not 0, are given by the quadratic formula. And you see your quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, we can use the quadratic formula to solve quadratic equations that cannot be factored. Now, you can use the quadratic formula to solve any equation, even in a quadratic equation that can be factored, you can still use the quadratic formula. However, some quadratic equations cannot be factored, and so we must use the quadratic formula to solve these equations. So we're going to start with example 5, and you'll still do the same thing that we did in those first examples, and that is that you want these quadratic equations written in standard form first, and then we're going to work these by hand using our quadratic formula. So if you'll look at example 5, solve x squared minus 4x equals negative 2. Then we're going to start by writing this in standard form. X squared minus 4x plus 2 equals 0. And make note that your standard form is ax squared plus bx plus c. So when you are using the quadratic formula, it is very important that you know what a and what b and what c are. So a will be 1 because there's an understood 1 in front of x squared as your coefficient. B will be negative 4, and c will be 2 according to the definition of standard form for a quadratic equation. Once you have noted what a, b, and c are, then you can plug a, b, and c into your quadratic formula. So we will have x equals, make note that your formula is negative, so it'll be negative b, and our b is negative 4. So it's going to be negative 4 plus or minus the square root of b squared. So negative 4 squared minus 4 times a, which is 1, times c, which is 2, all divided by 2 times a, and a is 1. So once you have plugged in your values for a, b, and c, then you simplify your formula. So negative times a negative will be a positive 4 plus or minus, and negative 4 squared underneath your radical, you will have 16 minus 8, all divided by 2. Underneath your radical, 16 minus 8 will be the square root of 8, all divided by 2. Once you get to this point, then you still want to simplify this the same way that we have in the previous sections. So the square root of 8 is not a perfect square, but it can be broken down. So you will get x equals 4 plus or minus the square root of 4 times the square root of 2 all over 2. And the square root of 4 is 2. So you get 4 plus or minus 2 square root of 2 all over 2. Now remember that you will simplify this fraction just like you would like we have done in the previous section. So as you look at 4, 2, and 2, 2 will go into all three of those. So this will simplify to 2 plus or minus the square root of 2, because 2 will go into 4 2 times, 2 will go into 1 1 time, and 2 will go into 2 one time. So your final answer for example 5 is 2 plus or minus the square root of 2. Now I do want to show you that you can work these examples in your calculator. So I'm going to show you that next before we move into example 6. I'm going to move these. Bring my calculator here. Now it is important to note your quadratic formula is under programs, and those programs do not come in your calculator when you purchase your calculator. So you can get these programs from your instructor or from an assistant in the lab. Should be able to load these programs for you. So the first thing you need to do is to get to your quadratic formula program. So you will hit program, and you will see that it lists your programs here. Depending on how many programs you have in there, you'll just want to scroll down. And it's actually called Quad 4 is what it will be listed as. So once it is highlighted on Quad 4, then you'll hit enter, and you'll notice that it'll say it at the top, and you'll hit enter again. And then it will ask you for your A, B, and your C. So if you look back to the example that we just worked, A was 1, so you'll type in 1 and then hit enter. B was -4, so you'll type in -4 and hit enter. And your C was 2, and you'll type that in and hit enter. Now at this point you will want to stop at this step, because if you go one step further and hit enter, it is going to give you decimal answers. And for this section, you're not going to want those answers to be decimal answers. So you will notice that you have 4 plus or minus the square root of 8 divided by 2. And if you'll look at your answer that we got on example 5, before we simplified, that is the answer that we got. So this is as far as your calculator will take it, and then you will break it down by hand, your square root of 8, just like we did when we were working it a while ago. So this will work the first part for you, but then you'll still need to simplify to your final answer. Again, this is your solution in the calculator to example 5, but don't forget to take that completely, to simplify that completely by hand. Now I'm going to put my our papers back here. You'll hit enter, by the way, you'll hit enter one more time, and it will give you those decimal answers. And once it says done, then you can clear that out to your blank screen. I'm going to go back to our papers, and we're going to work example 6 the same way, and then I'm also going to show you how to do it in the calculator as well. So on example 6, we have 2x squared equals x minus 4. So again, you're going to want to write this in standard form. So you get 2x squared minus x plus 4 equals 0. Make note of what your A, B, and C are. A is 2, B is -1, and C is 4. Plug this into your quadratic formula. So we have x equals, notice that your formula is -b, so if I'm plugging in -1, that's going to be a +1 plus or minus the square root of b squared, so -1 squared minus 4 times a, which is 2, times c, which is 4, all divided by 2a, and a is 2. And then again, once you plug in those a, b, and c values, then you simplify from there. So we have 1 plus or minus the square root, -1 squared is 1, minus 4 times 2 is 8, times 4 is 32, divided by 4. Continuing, we have x equals 1 plus or minus the square root of -31, all divided by 4. You'll notice that you have the square root of negative 31. So that gives us 1 plus or minus I square root of 31 divided by 4. Now the square root of 31 is not a perfect square, and 31 cannot be broken down. So this is your final answer. But keep in mind that MyLabs Plus usually separates this as 1/4 plus or minus I square root of 31 over 4. And then also it will want you to separate that, remember, as 1/4 plus I square root of 31 over 4, and comma 1/4 minus I square root of 31 over 4. Okay, so again, we did the exact same thing in example 6. Now I'm going to move these papers again. I'm going to put my calculator back up here. And we're going to do the exact same thing for example 6. So you'll go to your programs and you'll scroll down until you find quad 4. And again, we're working example 6, just using your calculator formula. And so our hit enter, and our A is 2. Our B is -1, and our C is 4. And you'll see that you get, it'll tell you that it's complex roots, so that lets you know that you are going to have an I in your answer. So you're going to have 1 plus or minus the square root of -31 divided by 4. So again, if you take this one step further, it's going to give you your decimal answer. So you want to stop here and you want to break it down by hand the rest of the way. But again, it is telling you complex roots, so you know you're going to have an I in your answer. Alright, let's put our papers back. Again, hit enter one more time. It'll tell you again your imaginary numbers, give it to you as a decimal, hit clear so you can get your blank screen. We're going to put our pages back up here and we're going to continue on. And now we're going to talk about cubic equations. Now, you will notice at the top that it says, remember, SOAP. SOAP helps us determine our signs for cubic equations. Alright, and SOAP stands for same, opposite, always, positive. And this will again help you determine your signs. So you will first factor a cubic equation, and when you factor a cubic equation, one of your factors will be a quadratic. So you will continue to work, you will work that part the same way we just did on example 5 and 6. And you can also put that quadratic portion in your calculator. So for example 7, I'm going to work it by hand, and then in the additional example, we will do that using the calculator. Alright, so for example 7, we have solved x cubed plus 8 equals 0. So the first thing that you want to do is solve this cubic equation. So remember that when you factor a cubic equation, you have a small parentheses and a big parentheses. And in that small parentheses, you're going to take the cube root of each term in your cubic equation. So the cube root of x cubed will be x, and the cube root of 8 will be 2. So that is how you get your terms in your small parentheses. And inside your big parentheses, to get your first term, you will square the first term in your first parentheses. So x squared. To get the middle term, you will multiply your two terms together in your first parentheses. You will have 2x. And to get this last term, you will square this last term in your first parentheses, giving us 4. Once you have put your terms in your little parentheses and your big parentheses, and that is where your SOAP comes into play. So again, same sign as what you started with, opposite sign is what you started with, and that last sign will always be positive. So since this was x cubed plus 8, same will also be positive. Opposite will be negative, and the last one will always be positive. So when we factor this cubic equation, we have x plus 2 times x squared minus 2x plus 4 equals 0. Now you still want to set each factor equal to 0, just like we did previously. So we have x plus 2 equals 0, and x squared minus 2x plus 4 equals 0. When we solve x plus 2 equals 0, we get x equals negative 2. That will be one of your solutions. And then to get your other two solutions, you will need to, this is a quadratic equation, so you will need to use the quadratic formula. Keeping in mind it's a cubic equation, it's cubed, and so you will have 3 answers. So again, we're going to work this second part, x squared minus 2x plus 4, the same way we did in example 5 and 6. So your A is 1, your B is negative 2, and your C is 4. So we're going to plug that in to our quadratic equation, keeping in mind that the quadratic equation is negative B, and this is negative 2. So that will be a positive 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4. 1 being your A and 4 being your C. All divided by 2A, and your 1 is your A. Simplify this. We have 2 plus or minus the square root of 4 minus 16, all divided by 2. And 4 minus 16 is the square root of negative 12 divided by 2. Your negative 1 will come outside of your radical as I. Square root of 12 will break down into 4 times the square root of 3. So that will be 2 plus or minus 2i square root of 3, all divided by 2. And again, since we have a 2 in all 3 of those terms, we can factor out a 2, and that leaves us with 1 plus or minus I square root of 3. So your first solution comes from here, and your other two solutions come from here. So if you were writing that as your solution set, you would have negative 2 comma, remember you want to write this separate, so you would have 1 plus I square root of 3, comma 1 minus I square root of 3. I've gone off the page. Let me scoot that back over. So this is your solution set for example 7. Now again, for this second part that we did right here by hand, you could again put that in your quadratic formula in your calculator, but once you got to this step right here, that's where it would take you in your calculator. You would need to break this down the rest of the way by hand so that you would not get a decimal answer. Now on this next additional example, we're going to do the exact same thing, but I am going to work the quadratic equation portion of this example in our calculator instead of doing that by hand. Alright, so let's look at our additional example. And it is solve x cubed minus 27 equals 0. So remember, we want to start by factoring. We do have that little parentheses and our big parentheses. Remember, to decide what goes inside this little parentheses, we take the cube root of both terms. So the cube root of x cubed will be x, and the cube root of 27 will be 3. To determine what goes in this big parentheses, then we square our first term, x squared, multiply them together, 3x, square this term, giving us 9. And remember, we're using SOAP. Same, opposite, always positive. So same as what we started with, we'll have a minus here. Opposite of what we started with, we'll have a plus here. And the last one is always positive. We'll set each one of these equal to 0. So we will get x equals 3 as one of our solutions, and then x squared plus 3x plus 9, our quadratic, we can put in our calculator or work that by hand. So your A will be 1, your B will be 3, and your C will be 9. Alright, so I'm going to bring the calculator here. And since I've already shown you the buttons to push, I'm going to just leave this side by side here. So we're going to go to Program. Again, we're going to scroll down. To Quad 4. Hit Enter. Enter again. Your A will be 1. Your B will be 3. And your C will be 9. Alright, and don't forget that you want to stop here, but again, make note that it tells you you're going to have complex roots, okay, and it tells you you have -3 plus or minus the square root of -27 divided by 2. So we will stop here, and we will keep this part from our calculator, and then we will simplify the remainder by hand. So I'm going to move the calculator and write that. X equals -3 plus or minus the square root of -27 divided by 2. And remember, this came straight from our calculator. So we didn't have to do the whole first part by hand, but now we will have to simplify by hand. So -3 plus or minus I square root of 27, and the square root of 27 will break down into the square root of 9 times the square root of 3, all divided by 2. -3 plus or minus the square root of 9 is 3, so you get 3i square root of 3, all divided by 2. Now make note that we have 3, 3, and 2. That cannot be simplified, so you will leave that as is. However, remember that MyLabs Plus in your book usually separates this so that it's -3 over 2 plus or minus 3i square root of 3 over 2. Alright, so if we are writing the solutions for this, remember your one solution comes from here and your other two solutions come from here. So your solution set would be 3, comma, -3 over 2 plus 3i square root of 3 over 2, comma, -3 over 2 minus 3i square root of 3 over 2. So again, one solution comes from here and your other two solutions come from here, but remember MyLabs Plus wants you to separate those answers instead of writing it as plus or minus. Alright, so it's important that you know how to do the quadratic by hand, but also you can solve quadratic equations using the program in your calculator. And don't forget that that does not come in your calculator when you purchase it, but you can get that program from your instructor. Now, if you will try exercises 13, 29, 31, 53, 57, and 69 from the book. And again, those answers or your solutions can be found if you click on Answers to Selected Exercises in the glossary. This does conclude section 1-4 on quadratic equations.